Guys, today's video is on more about imaginary numbers. Specifically, we're going to talk about complex numbers. Complex numbers are basically a real number and an imaginary, but added or subtracted together. Here, the 5 is the real part, and the 2i is the pure imaginary number. You can't combine them to make 7i because they're not like terms. Again, think of the I as like a variable. The standard form for a complex number is a, which is the real part. You do plus bi, which is the imaginary part. And when we add and subtract these, we're just going to combine like terms. So we're going to add the real parts together, and we're going to add or subtract the imaginary parts together. For example, in number 1, we have negative 11 plus 9, which makes negative 2. But then 3i plus 2i is 5i. And you leave it just like that. Make sure that the real part comes before the imaginary part. Looking at number 4, here we just have some distribution first. So we're left with 6i minus 14 plus I plus 5 minus 3i. Then we can combine like terms. The real part is negative 14 plus 5, which is negative 9. And the imaginary part is 6i plus I minus 3i. That makes 7 minus 3, which is 4i. And you can leave it just like that. Let's keep moving on. Distribute and multiply and FOIL imaginary numbers. Recall over here that I squared is the same thing as negative 1. So distributing here, we get 2i times 8. Even if you have a real and an imaginary number, you can still multiply them. You just can't add or subtract. But we can multiply them to make 16i. And then 2i times negative 3i. 2 times negative 3 is a negative 6. I times I is I squared. But we know and recall that I squared is the same thing as negative 1. So this is like saying negative 6 times negative 1, which turns it into a positive 6. And then we have the imaginary part, the 16i, after. Let's do another one, but let's FOIL. So distributing the 2 to the negative 5, we get negative 10. 2 times negative 3i is negative 6i. And then this FOILing here, negative 4i times negative 5 is a positive 20i. And negative 4i times a negative 3i is a positive 12i squared. But again, recall that an I squared is the same thing as saying negative 1. Now we can combine like terms. Negative 10, and this is going to be a negative 12, makes negative 22. And then we have negative 6 i's plus 20 i's is a positive 14i. And this is your final answer in standard form. Write down what questions you have on adding, subtracting, and multiplying imaginary numbers. Let's quickly talk about an important vocab term called the conjugate. What a conjugate is, it's the kind of like the opposite of the complex number you have. For example, if you have a plus in between the a and the b, it's going to be minus, and when you have a minus, it's going to be a plus. So these two terms, the 8 plus I and the 8 minus I, they're called conjugates of each other. Let's multiply and see what happens when we multiply two conjugates together. Let's FOIL. 8 times 8 is 64. 8 times negative I is negative 8i. Then we have I times 8 is an 8i. And then an I times a negative I is a negative I squared. Remember that an I squared is the same thing as saying negative 1. But what's going to happen, the important part, what's going to happen in the middle, is that the i's will end up canceling. So we're simply just left with 64 plus 1, which is 65. The point of this is saying that when you multiply by your conjugate, the imaginary part, the i's, are going to end up going to cancel, and you're going to simply be left with a real solution. The last part we're going to talk about is if you have an I on your denominator. So we do not want an I on the denominator. It's not really simplified enough. So what we're going to do is if the denominator is a monomial, just like numbers 13, 14, 15, 16, you're going to multiply the top and bottom by I. Let's do that. So I'm going to multiply the top and the bottom by I, which is basically saying you're multiplying by 1, but we're going to simplify the denominator. The top is going to become 10i, and the denominator is going to be 2i squared. But an I squared is the same thing as -1. So this is just like saying 2 times -1, which is -2. This isn't simplified yet. Even though the i's out of the bottom, we can still divide the coefficients here, the 10 and the -2, because you can do multiplication or division with i's and real numbers. You just can't add or subtract them. 10 divided by -2 makes -5. So your final answer is -5i. Let's do one more of these. Let's do 15, and then we'll get to a binomial. Number 15, let's multiply the top and bottom by I. The top becomes 28i, and I'm going to do this all in one step, this distribution. -8i times I is -8i squared, but then again, I squared is like saying -1, so this becomes a +8, and on the denominator, 4 times I, or 4i times I is 4i squared, which is like saying 4 times -1, which is -4. And then we can continue simplifying all the numbers you see. It's just like saying 2 fractions. So you can simplify them all by 4. Dividing out that 4, and we can even divide at a -4. We can divide this to get 7i, -7i, and we can divide these to get -2. And there's your final simplified answer. So saying 28i plus 8 divided by -4 is just like saying dividing 28i by -4, and then separately dividing 8 by -4 to get your final answer. There is a mistake here. Think about what mistake that I wrote. The mistake here is that I did not put this into standard form. So you need to write it backwards, putting the real part first and then the imaginary part. Good catch if you caught that before I went on. We're going to do one more problem where the denominator is a binomial. Number 17, when you have a binomial on the bottom, we need to multiply not the top and bottom by I, but we're going to multiply the top and bottom by the bottom's conjugate, which is 5 plus I. On the top, we're going to do some distribution to get -10 minus 2i. On the denominator, after foiling, you should get 25, and the i's will end up canceling. And then -I times I is -I squared. Simplifying that I squared is -1. So it's going to be just like saying 25 minus -1, which is saying 26. Simplifying each fraction now, again saying that you can divide these two and get a -5/13, and then dividing this fraction separately, we get -1i divided by 13. And here's your final answer written in standard form, real number and then imaginary number after. The conjugates are going to get some time to practice. It's a little more confusing. I think the adding, subtracting we can all do. Again, the most important part is saying that I squared is -1 and changing that accordingly. Have a great night, guys. See everyone next time.